for joining the panel discussion on BioE3. So our experts are also joined. Unfortunately, Dr. Vamshi, who is representing Department of Biotechnology, is unable to join because he has another function today around the same time on BioE3, which is actually he is coordinating where Secretary DBT is participating. Therefore, he is unable to attend the program. So first and foremost, I will welcome our panelists and then we will start the proceedings. So our colleagues and students from our second campus, Sakulam, is also attending from there because this program is getting live streamed there. So to begin, before I go into the BioE3 details, I will first welcome all our eminent panelists. So our panelists include Dr. G. Patmanabhan. Definitely doesn't need any introduction to RGCB, but it is my pleasure to invite Dr. G. Patmanabhan, former director of IAC, to this function. And also on behalf of RGCB family, I congratulate him for receiving the Vigyan Ratna 2024 award.
Thank you. Thank you.
Thank you, sir. Our second panelist is Dr. Ram Rajsekhar. He was at IAC and he is currently is a professor of microbiology at the Central University of Tamil Nadu. I welcome sir for today's program. Our third panelist is our own scientist, Dr. T.R. Santosh Kumar. I welcome you sir for the program. And the fourth panelist is Dr. K. Ambadi. So some of you definitely know him. Dr. K. Ambadi, IAS. He is the Chief Executive Officer. He is just recently appointed as the Chief CEO of our BioNest, which is an incubator facility of RGCB located at Kochi. So to begin, I was told by the DBT, especially Dr. Vamshi, to share 3 slides and a small video. It won't take much time, and then we will move on to the panelists. So as you all know, our country is actually showing a very remarkable growth in its economy. So identifying and executing newer technologies and innovative solutions will help in the growth of economy. And nowadays we are hearing a lot about biomanufacturing, and which holds tremendous potential to increase the sustainable potential of biological system. So if you give a definition to biomanufacturing, it's nothing but we are using engineered plant or animal or including human system or microbial system to increase the precision and control to produce commercially important products on scale. So with this, government come up with a policy which is called BioE3 policy, which is basically E3 stands for economy, environment and employment for fostering high performance biomanufacturing. This is the BioE3 logo, where we are actually the part along with our media team, actually we designed the logo for BioE3. That's the logo we are using it. And why this is so important? Because the ultimate aim of the policy is to strengthen government vision on green growth, net zero economy and lifestyle for environment. So eventually this policy is to promote biomanufacturing in the country. So it's not just going to happen in at like one institution. So this required partnership and collaboration at the national and international level, setting up public-private partnership, generating trained manpower and coordination among different ministries. Because that is also very important, because we have to modify because it's very essential to modify or make appropriate regulations and incentives which will reduce timelines of development and commercialization. So we hope that biomanufacturing will play an essential role in the sustainable development of current and future generation and will play a significant role in achieving the target of Vikasit Bharat by 2047. So these are the things which was actually been shown. So this is the BioE3, the living system coupled with the engineering, the synthetic bioengineering and precision fermentation. And finally, this is a strategic roadmap which we are going to listen now from our expert. And since our audience consists of both faculties and students, so especially the student population also should be aware about these developments. So I first request Patmanabhan sir to give his thoughts on this BioE3 policy.
Thank you. Thank you for inviting me for this panel discussion. Also thank you Ram Rajsekhar and Pradeep and experts from RGCB. Now, already it's explained, E3 stands for employment, economy, and environment. So, what is the main crux also has been pointed out, that is biomanufacturing. So, biomanufacturing of what? So, biomanufacturing essentially, for example, biopolymers, manufacture of enzymes. These are all, earlier we were all looking at chemicals, drugs. Now we are looking at biomolecules as drugs. Enzymes, hormones, which are proteins in nature, which have many applications. We know industrial applications, starch degradation, etc., etc. But they also have biomedical application. So that is one aspect of biomanufacturing. Functional foods, and what we call as the second aspect is smart proteins. For the benefit of students who may not be aware, what are smart proteins? Proteins are, normally of animal origin. Can you replace these proteins with plant proteins, with bacterial proteins, microbial proteins as foods? These are all newer concepts, we are not used to using. Mostly we have been using animal proteins and perhaps plant proteins as well. But the important thing that has come into what E3 policy would be also look at microbiological sources. So, first aspect in biomanufacturing is fermentation, as was pointed out. And most important in this aspect is generation of carbon dioxide, this is part of the climate mitigation program. It's a main issue has been climate change and release of carbon dioxide. Release of carbon dioxide from all chemical processes. The advantage of biomanufacturing is in a closed system. That means you are using a fermenter. That means there is no escape of the system as such. So that is a very important emphasis which government is perhaps giving in biomanufacturing using fermentation process. And the main objective being generation of carbon dioxide is prevented. We always minimized, we can never say prevented. The other approach is to capture the environmental carbon dioxide. There is so much of carbon dioxide in the environment. How do you capture? So there are, zeolithic materials which can absorb carbon dioxide from the environment. Therefore, is it possible to remove as much of carbon dioxide as possible? And when it comes to healthcare, newer concepts will become like personalized medicine. Vaccines became, for example, let me first start with vaccines. It was not such a, in my opinion, popular thing before COVID came. after COVID struck, and vaccines became a very major, even public started understanding what are vaccines. And conceptually it has been that vaccines will take, say, a decade to manufacture. But COVID example showed in a couple of years vaccines were manufactured. As we all know, the S protein of the COVID virus, that is the target for everything. And one could find that vaccines could be made, and almost within less than 2 years, and AstraZeneca vaccine, recombinant protein, S protein can be made, which is a vaccine. Therefore, vaccines have become a major tool now. Not that it has become new, in that sense it's known for ages. Vaccines have saved millions of lives. But there has also been a propaganda that vaccines are dangerous, vaccines can cause infertility and so on. This is all propaganda against vaccines. But if you look at literature, human evolution, vaccines have saved millions and millions of lives, actually. Other one that's very important, so biomanufacturing, vaccines, etc. Personalized medicine. So the new approach is going to be personalized medicine. What is personalized medicine? One of the component of this E3, etc., is genome sequencing. Once you have genome sequencing available, that means human genome sequence, for example, that has been the ultimate. Now, in India, we are very far behind, I should say. I remember I chaired this committee for DBT. I said we have to start somewhere. At least let us sequence 10,000 Indian, 10,000 normal Indians. We should sequence. Some of you may be aware, the minister a few months or a couple of months ago announced, India sequenced 10,000 Indians, sequences available. Now this is too small. We have a population of 1.4 billion. So to say 10,000 Indians is not a representative sample at all, but we have to start somewhere. Because we need technology. New generation sequencing technologies are changing very fast. Therefore, is it possible to sequence? And as you know, India is a very heterogeneous population. Forget about disease population. Even normal Indians, if you take, we come from, for example, even different states. Although we say 99.99% of our sequence is identical, still we are different. We look different, we behave different. One of the reasons is probably expression of it. I hope the students know the genome sequence codes for genes. Of course, interestingly, hardly 1.5% of the human genome codes for proteins. Rest of it, you must be asking the question, why so much DNA when only 1.5% is used for proteins? Because, of course, DNA plays very many different roles, regulatory roles. Maybe it will come out during discussion what are all the possibilities of DNA. So the genome sequence, once it is known, gives room for personalized medicine. That means Even infectious disease, somebody is susceptible, somebody is not susceptible. We are all exposed to the same environment, let us say. Even then, everyone doesn't get tuberculosis. Of course, nutrition, environment, all of them play very important role. Here I am just talking about genome sequence. To what extent it plays a very important role. And once it is known, personalized medicine, there is room for gene therapy, for example. Maybe, we can explain it a little more later. Targeted cancer treatment, stem cell therapy, tissue engineering, all these are, part of personalized medicine. So this is the health aspect, and then quickly I will also go into agriculture. In agriculture, you have genetically modified crops. India, probably we have not accepted genetically modified crops. The only crop known is BT cotton. Other than BT cotton, no other genetically modified crops is accepted in India. Of course, there is a lot of activism against. It's unfortunate, in my opinion, we are losing a great opportunity to utilize this technology. It causes resistance against pests, resistance against climate change, temperature. All these are possible using genetic modification. And apart from genetic modification, that means introducing new genes from outside. But even better option is gene editing. That means you don't bring a gene from outside, but existing gene can be modified. That is known as gene modification, gene editing. Why not use gene editing? Can you use gene editing approach to introduce resistance, like resistance to pests, resistance to, this was possible by using genetic modification. So these are all approaches to, in agriculture, basically, last point I want to make is it's a circular economy. From waste, you generate products and it goes back to the waste. So that is where the BioE3 policy says basically you use biomass to generate products from biomass and it will go back. Therefore it is a circular economy. So these are some of the aspects, points I wanted to point out. There are a few other aspects about, it's already mentioned that India's economy is about, it started at $10 billion US in 2014. It is catching up to $130 billion in 2024. And $300 billion is targeted in 2030. So I will stop here and maybe request the other panelists to offer their comments and perhaps we can answer questions and take a discussion. Thank you.
Good morning, all of you. It was a pleasure to be part of these discussions, and thanks for inviting me as a part. My special thanks on a Teachers' Day, and as a GP, I wish you a happy Teachers' Day. Then I had these documents was put out very beautifully, and it talks mostly about these E3 components. But when I go through the entire documents, the number of projects which are put on energy and environment is relatively low in the entire document. It is worthwhile incorporating some of those, how we are going to really address the energy crisis, how are we going to address some of the environmental crises. Ministries which you have included food as the part, and there is a Ministry of Food Processing Industry is not incorporated as the part of the ministerial interactions, because they also have a large number of projects to manage. And it is one of the best programs where DBT has come out at the modern times. And the DBT has come out with an assumption they have a fantastic DBT institutions, and these enablers has to be immediately implemented to understand, at least to move forward in this direction. What I would suggest or what I feel is there are institutions, DBT institutions, they are specialized in many areas like pharma, even materials, even for agriculture and smart protein. Many of these ones are there. These enablers can be started right there as a part of their organization, and that way the kickstart can be done. Because just giving a policy document, and the policy document is not defining the short term which we are trying to address and the long term which we are trying to address. And this gives at least the push to the entire program, where people start seeing the benefit of this entire BioE3 program. For this, we should identify not only the institutions, a problem which our common people are currently facing, like single-use plastics, even agriculture. Then we are saying we should use less amount of fertilizers and so on. Can we really make the change in the soil microbes and demonstrate there is a yield increase is happening? And such kind of a simple project which actually touches the lives of everyone. Then this program becomes very aggressive. And when it comes to the food part, then we have many different things to really do. And we are trying to create food from microbial source. Why can't we, the government of India permits us and make policy changes to bring in the amount of yeast which is being thrown out, even after the distillatory industry? Why can't we use these entire yeast as isolate proteins or lipids from them and start using it right away as a part of the biomanufacturing? Because these kind of programs has to be put in to really drag attention of the public, attention of all the administrators as well. That was one of my part. Then when we talk about the newer things like that smart protein, because soybean is being used very extensively to study this part, we need materials to strengthen these proteins. And the amount of research which is done to really understand cooking and protein. Cooking and protein. People think, okay, you take a protein and then you cook it, that protein becomes much stronger. It is unable to digest. It's more like a material which is stronger. But it is time we should also really look at the technologies to come in and intervention on those processes to see whether these disulfide bonds can be broken, and thereby we can at least loosen the food and it will be easy for digestion. But some of these projects has to be delineated as a short-term goal. I'm giving you a representative examples of some of those biomanufacturing which is currently needed to do this. And then we can also list all the long-term processes, and that would be worthwhile. That way, the policy is not only that there are two things in this policy which is listed. If I have a food which is a smart food, if I go to Food Safety Authority of India, and it takes years to get a license to put that food into a market. But those changes has to be really upfront, we need to really put in. This is even though I was I'm chairing one of these fats and oil session in Food Safety Authority, when I put an application, it took almost 8 months to get an approval. 8 months to get an approval. Just using a biocatalyst as the way to really manage many of the fermentation processes. This is very simple. And these kind of regulatory changes has to come in to really enable them. That has to be very clearly spelled out, or we need to bring them into this folder of BioE3 and ask them to clear these smart ones at the fastest way. And these are some of my smaller observations, and which I have seen some of this. Some of these are my personal experience as well. It's one of the fantastic process which we have been doing it, but now we have brought into a formalized and a galvanized effort to do this part. But still, I strongly believe and feel all the DBT institution has to take each of these branches and create the facilities required to really do all these biomanufacturing which is required, which includes organoid, even tissue typing or tissue culturing. All these plans has to be really planned by each of these DBT institutions. And these institutions will be specialization. All these manufacturing personnel on a particular area can go and get their problem resolved for two reasons. Your program to sustain, you need to have developing manpower, and that is very, very important. All these institutions already have enough manpower, and they can recruit more to focus on particularly on biomanufacturing. We also start developing skills which are required for the entire development of this entire economy. This bioeconomy can be improved on this part. And this was my humble submission for each of these institutions who should take up, use their facility, and then advertise in such a way that most of those private people come in and use the facility and move on. The last point which I wanted to really say is, when BioE3 can be a symbol for most of the manufacturers. Like if you have a BioE3 symbol, it also stands for a company is doing a zero waste program. Can we create this logo and introduce this logo as a part of their product display, where you will have a better advertisement for this program. And number two, at least how many companies can really achieve these zero waste programs. And these logo can be used very effectively and used in every product where they have zero waste program. That is another way to really galvanize this program. Thanks for your time. I truly appreciate. If there are any questions you have, we'll be happy to really answer these. Thanks for your time. Thanks for giving me the opportunity.
Thank you, sir, for your views. Now I request Dr. T.R. Santosh Kumar to express his views on the BioE3 policy.
Thank you, Hari. First of all, it's great for me to have this opportunity to share my thoughts about the new policy which is being formulated by Government of India and also by the Department of Biotechnology. And many of the important salient features of the program, as well as what actually this means to us, already has been discussed by Padma Sir as well as Dr. Ram. So actually, I think you might have got an idea what it is actually, for the benefit of the society as well as the country, in terms of the three areas like economy, environment, as well as employment opportunities. And as we explained, that biomanufacturing is not, as for a biotechnology, it is not a new concept. And we can consider that we are currently in the phase of third generation of biomanufacturing, or probably we are just transiting into that fourth generation now, from the first generation where we have used only the microbes, primary metabolized, and then the second generation of using secondary metabolized. Then third generation we started in 80s, where we have gene sequencing has opened up a lot of opportunities to generate products using DNA, recombinant DNA technology. Actually, that is something which is revolutionizing the whole area now. And now the next phase is basically much more challenging. And many of the innovative biotechnology technologies, such as synthetic genes and direct evolution, all are going to help us to make non-existing cells as well as products actually in the nature, in the laboratory using biotechnology. So basically, we are at present in the third to fourth generation of biomanufacturing practices. Now, you need to know why this is actually now concept, and the policy is not globally. If you look, it is not new actually. The importance of biomanufacturing has been appreciated early by other countries as well. In 2023, USA also drafted a policy of similar kind of policy, and well before that, China also. And the primary reason for shifting towards biotechnology for production in agriculture and pharmaceutical industries and obviously chemical industries, that so far we have used a chemical-based means of production actually that had created a lot of problems on the environment as well as safety of the products. And this almost all the countries realize over a period of time. So now it is a time to think of using biotechnology, which obviously not always, many times will provide safe as well as the products in a cyclic manner. Actually, that is what the ways which we are producing. Already we have seen that bioplastics. We wanted to replace the plastics which is there, which is making havoc. Using biotechnology, a lot of bioplastics are coming. But in this case, what is very important for an institute like RGCB is that many of the thematic areas identified, bio-based chemicals and enzyme, functional food and smart proteins, and precision medicine and biotherapeutics, and obviously biofuels, and marine science, as well as AI-enabled technology development. All these are the priority areas identified as a draft policy, actually. And as Dr. Ram has mentioned that several of the important points which were actually you cannot find in that. But obviously in the framework more and more activities will coming soon. Unfortunately, Dr. Vamsi is not here actually. If he could have actually revealed much more insight into what are the programs which has been identified, the different sectoral committees formed at the DBT, which falls under the 6 thematic areas. Actually, so many things were actually planned. Actually. All this will be going to come one by one over a period of years because it's something which they are aiming to achieve this goal of economy as well as environmental safe products and also employment generation up to to everything has to be fulfilled in a long time goal of 2047 actually. So programs will be coming, and how actually for us. The question is that how we are ready to exploit these opportunities actually. And now what are the other initiatives already, this is only a policy actually. And the policy is only a framework of things which the government wants. And many things, execution phase, a lot of programs needs to come. Then only the clarity will evolve actually. And when very carefully look at the developments of the DBT as well as Government of India, whatever they have initiated, when you look, some of the programs, one is that, and through BIRAC, they started a program of biofoundry establishment as an AI-driven bio-enablers. That means that it is assumed that as a country and biotechnological capability in academic settings, we are capable of generating new products as well as processes meant for the industry. But only problem is that the level of industrialization and scaling up, we do not have actually sufficient facilities and ecosystem in India in place actually. That is why the primary importance DPT is giving. Already they have opened a call for establishing biofoundries through BIRAC actually. That means it's actually an automated production capability centers needs to be established, multiple centers, the call is open, still people can apply for that actually. So these centers probably depending on our capability, if somebody wanted to establish a bio-enabled hub for enzyme productions, linking multiple institutions as well as industries, this is possible. And that means that Government of India has very clearly realized that the important lacuna is that scaling up of products from the institutions, academic settings, lab to next level, we have a lot of hurdles. We need model ecosystems actually, and that is the first step actually. That program is going on. And now coming to us, what are the opportunities? Very carefully, if you look, these activities, bioprecision, smart food, all are actually biotechnology-driven product or processes being proposed. And we are capable of exploiting all this because we are truly a biotechnology institute. Similar to that, another aspect because this aims for employment generation in biotechnology. We have I'm most happy to see that a lot of MSc students are over here actually. You are all trained in biotechnology skills and resources actually. So you are a very highly trained resources. So you are going to be the real beneficiaries of this changing environment in the coming years actually. So that is another aspect I would like to emphasize this. One more point I would like to tell you now. And in the precision medicine, when our personalized medicine, if you specifically EBT identifies as an area, this doesn't comes only with the specific target of the therapy. And if lot of resources which are required for a therapeutic development has to be developed in a self-reliant manner in India make concept actually. If you see, we have developed vaccines. We have conducted trial for COVID vaccines in a short period of time. We have diagnosis which developed for the, all this very specifically look, India-made diagnostics, India-made resources, all these were developed short period of time. When very carefully look on those products, you will find that the specialty reagents, most specialty reagents used for tailoring those cases or diagnosis came from abroad. We imported many, not even today, many of the specialty products, biologicals, recombinants, and therapeutics, obviously and many things we are importing. At the same time, as a biotechnology students and laboratory investigators, we used to do this regularly in the laboratory, those kind of reagents, and developing for the scale for which it is required for research, actually. So now it is a time to think that how exactly these skills and resources and technologies we can adapt to the increasing opportunities which is coming up along with the biomanufacturing. And with this, I will stop. Obviously, after hearing, we will again come back how exactly this policy is going to help us specific, domain-based manner that we will discuss later. Thank you.
Thank you, sir. Now, let's hear from the startups and the industry perspective on BioE3. So now I invite Dr. Ambadi to share his views on the policy.
Good morning to all of you. Dr. Patmanabhan, Dr. Ram, Dr. Santosh, and friends and colleagues. Probably I may be the only person who is not from a biotechnology background in this entire crowd, probably in this entire room. As the CEO of a biotechnology incubator, I would like to see this policy from that perspective. Most of us would be hearing motivational speakers. Now motivational speakers are all out in the YouTube, Instagram, Facebook, and many of them would always advise us that you have to utilize or address the challenges you face and convert them into opportunities. Most of the times, these are plain speaks for many of us. But I feel that this new policy on biotechnology, unveiled by the Union Cabinet and exposed by our Union Minister, Dr. Jitendra Singh, last week, is a very recent example of trying to address some of the immediate and palpable challenges that we face and convert them into economic opportunities. We know if you step out of RGCB, if you go into the city of Trivandrum, one of the important challenges or issues which we face, as we all know, is waste. And probably some of you from Trivandrum would be knowing the struggle that has taken place, the protest that has taken place in a place called Velappilshala, because somebody was trying to implement a technical solution for the issue of waste management. So that is a very pressing challenge issue that we face. Similarly, another issue that we face, a palpable issue, is of climate change. We are now facing it. Extreme heat, receding sea lines, so many issues which we are facing, and because of the health challenges that we are facing because of the change in climate. So this BioE3 policy is trying to address these pertinent issues, these challenges which we are facing, and convert them into economic opportunities. So waste generation is an area which they are trying to address. Climate change is an area where they are trying to address. And non-sustainable way of material consumption is another area where we are trying to address this issue. So BioE3 is actually trying to create opportunities. For example, if we are having a biotechnology-based solution, socially acceptable solution, technologically wise solution to be to manage the waste in Trivandrum. Definitely it will create employment, and that employment will generate market activity, it will boost the economy, and it will be also environment friendly. And these are the three pillars of BioE3: environment, economy, and employment. So all these things are linked. So we are getting an opportunity to find solutions, biotechnology-based, bio-based solutions for some of the issues which are very pressing and palpable to all of us. So that is the fascinating aspect of this policy. So from a point of view of a biotechnology incubator, one of the interesting aspects which I found is an thrust on innovation-based research and focus on entrepreneurship. Most of you are biotechnology students, and some of you may be having that fire of entrepreneurship in you, that you want to create something of your own and make it into a biotechnology unicorn maybe a decade later. As Padmanabhan sir was saying, the economy was something like maybe $13 billion in 2014. It has become 13 times, 130 times it has become, 13 times it has become 130 billion. So when we are actually talking about these numbers, it may not make much sense to us because we are actually talking it from a national perspective. But if you say that, take the example of the revolution in 1990s, IT revolution contributed 1.2%. The IT growth, the IT was contributing 1.2% of the country's GDP, and it is now contributing around 8%. This also will not make any sense. But when I give you a personal example, that Narayana Murthy borrowed 15,000 rupees from Sudha Murthy to invest in Infosys, and Narayana Murthy now holds 30,000 crore in his bank account. As he stated, then it will make sense to all of us. So what is the kind of growth that has happened? We have seen Sudha Murthy herself saying this in various platforms. So that is the kind of opportunity that is available to all of you sitting here. If you have an idea, if you have an idea that can be developed, this is an opportunity that is available to all of you. You have a very good institute here, you have an incubator, you have very good teachers, scientists who are willing to help you. So develop that idea and utilize the opportunities available as part of this policy. Because when the IT policy was made in 1990s, everybody didn't become Narayana Murthy. Everybody didn't become Nandan Neilakani. But some of them who used that opportunity to tap on that opportunity made history. So this is an opportunity for you people to create history, utilize this opportunity and create biotechnology unicorns of your own. So that is the very pedestrian kind of understanding which I have. I am not a technical person. So this is the general understanding, the economical understanding I could get by having a very superficial read of this policy. So I think there are eminent panelists who can answer your technical questions. So with this, I rest my case. Thank you.
Thank you, Dr. Ampadi. Before I open the forum for discussion, I have like 4 specific questions to each of the experts, starting with the Padmanabhan sir. Sir, if you look at the chemical industry, so it is basically contributing to about 3% of our GDP. Okay, and now we are talking about like biomanufacturing. So that means, and we are thinking that that will be also going to contribute to our economy as well as in the GDP. So a question, because at the institute level, since we are all working at in the academy and in the institute, the question is, are we prepared, or where are we standing now, and what are the ecosystem immediately needed for us to venture into the biomanufacturing? So if you could just give your output, or if you give your thoughts on this, that will be very helpful to many of us.
Thank you. Now, first of all, we should be clear as to what we want to biomanufacture. Biomanufacturing is a process whereby we will reduce the carbon generation to the environment. It's all clear. So it has become very important, with climate change, etc. It's a very important approach. So what we want to biomanufacture? Basically, when you say biomanufacturing, you talk about fermenters. Do we have enough fermenting capacity or fermenter capacity in this country? Do laboratories have adequate fermenters? I'm not very sure we even have 5 liter, fermenter in the laboratory. Therefore, it must be very clear to us what do we want to biomanufacture. Do we want to biomanufacture enzymes, protein as foods, or microbiological sources? We want to process them, isolate proteins, and then popularize them as food material. One has to be very careful with food. Food is a personal choice. So it's very important, that, when we say this can become a food, that can become a food, people will not accept it. For ages, eons, we have been used to a particular way of eating, particular way of food, and whether it's possible. Therefore, all this become important when we try to change things, actually. But one thing is clear, animal proteins have to give way to either plant proteins or to microbial proteins. Now, this is it's becoming clearer and clearer. Is it possible? And what are all the technologies that we need to use them to manufacture them and become, of course, there are a few components already known, but is it possible to manufacture? I don't think we have too many manufacturers in this country who are doing biomanufacturing. We are still in the chemical process industry. There are very, very few biomanufacturing processes that are available in this country. I'll stop here.
Thank you, sir. So the next question is to Dr. Ram Rajshekhar. So it is expecting that our country will have about 1.67 billion population by 2050. That is the current estimate. And one of the major challenges is that we need to have adequate food and nutritional food initiatives. And this BioE3 policy specifically says that we should, because it actually support or it's strongly emphasis in to facilitate the production of smart proteins and functional foods and with a low carbon footprint using synthetic biology. So coming to this, how the current existing policies in our country will allow, because in the beginning I already mentioned that we need an intra-departmental or inter-ministerial connection or intra-ministerial combination in order to implement this. So since you are an expert from that area, what do you think about the current policies in place? Do we need to change, or that is sufficient to achieve this dream of making smart proteins and functional foods?
Thank you. Now, let us come back to his agriculture. In India, at this time, we are really producing more than what is required, most of the grains we produce. Anyway, in 25 years from now, we have enough starchy material in our hand. There is no doubt about it. There is only two material which we have problem. We are deficient as a part of this, as an oil is, we are deficient as a nation. And think about the food, the amount of oil which is being brought into the country is so high. Even approximately 63% of our consumption, the oil, the edible oil is not coming from the country, it's coming from outside. It means there is a great lacuna which is there on oil. It is a similar thing which is also there in protein. It's a very interesting thing about protein. If you look at overall production of protein in our country is wonderful. We can say it is sufficient. But the quality of protein which is coming from the plant source is going to be the difficult. It is not the quality of the protein, because we have difficulties in making the protein bioavailable for us. That was one of the major challenges which we need to look at it. Okay. And If you look at even after 25 years from now, it is 2050, we are starchy material, no issues. And oil, we have long way to go. Protein, we have achieved the self-sufficiency, but still that protein is not bioavailable with respect to, we call it as a smart protein, is which is much lower. When you decided to really do a simpler way, let us really have a simple way of the policy. If I have decided to really have a microbial oil as the replacement, when I go to Food Safety Authority of India, and they are going to take years to give that, that policy change has to come in. Policy change has to come in with respect to there is a new material or new product or new food has been really planned. What is wrong with this food? As long as it is triglyceride is the name of these molecules, it is isolated from yet another biological system. Why these agencies are taking quite a lot of time and reject. Forget about whether market, a consumer may reject this food. That's a different story. But regulatory authority has no reason to reject this. Okay. That change has to be brought in with respect to including a smart protein, which we need to really see. What is here in smart protein? Here, we also talk about even meat-like proteins and so on. It's mostly, we work mostly on only soy protein. Soy protein or a pea protein. The family of these Leguminosae family only, we have been concentrating on this. And it is the time to really look at it. Can we make these proteins bioavailable in a simplest in a biological process? Where instead of really talking about, we always use egg protein as the reference material to really understand whether this food is highly digestible, easy to take it out in our system. But there is no plant food has come closer to this. Can we make that protein, that making the plant protein as a smart protein? And where is the biological intervention has to be there? The seed normally produces the protein and make them so compact by just removing all the water. But when we try to cook, the amount of energy required to cook that food is also very high. That is not a problem. Can we really find a biological way to loosen out these entire process, especially loosen out these proteins? Then cooking time can be very simply lowered. When cooking time is lowered, the amount of energy and time is also saved as a part of it. Because it's one of the biggest programs which we say, which comes under the category of energy as well. Now, when we have these kind of a treatment, now they are asking, regulatory authority comes in and asks a question. Oh, you have modified, this process is not done by anybody, even though the process is an innovative process, a biological process. But these regulators will regulate, making sure this product is not reaching people on time. And when do we really regulator really starts giving these ones? When the situation like emergency, when COVID hit us, what we do? All clearance are done just as fast as we can. Can we have a similar same country? Problem is there. And why can't we have a similar mechanism or mechanics to really understand to the regulatory bodies to really give the license to go ahead, even which includes genetically modified material also. But in my opinion, at this time, we have enough of biomaterial and that can be converted into a food and our population, Indians, has to accept those kind of a food. And that is actually a consumer preference will come in the later part. Because we are an agriculture country, all residues have whatever the material which you are looking for. We never exploit. Because even though amount of cellulose is so high from plant material, we grow cotton for cellulosic material. Well, why can't we isolate a pure, instead of growing a cotton plant, why can't we take a plant residue and isolate cellulose? It has minimum 33%. Concentration is low, but you need not do agriculture. You're taking waste material which can be done. But these are all the materials, we have enough materials through agriculture. Can we make these materials into a smart protein or smart chemicals or even a smart food? Thank you. I hope I try to address your question with the examples. Thank you very much.
Thank you, sir. So now moving to the Dr. T.R. Santosh. So one of the important area under this BioE3 policies, they are promoting cell and gene therapy, because we are looking at the futuristic biotherapeutic technologies, because we already talk about personalized medicine, because we are going for cell and gene therapy, then mRNA-based therapeutics, monoclonal antibody productions, and other, and especially not only for our country, because we wanted to have a position at the global level for our country. So that is, and so creating a hub in our country, that is one of the important importance of this particular policy, or that is the policy is actually looking for. So in this context, my question to Dr. Shriya Santosh is, at the institutional level, where are we standing? So what we need to do in order to reach into that level, at least in maybe in the next 5 years or 10 years, at the institutional level, what are the things we need to conduct?
Thank you, Hari. Actually, now, you see, cell and gene therapy is a revolutionizing field of treatment in many diseases, including cancer, actually. We have seen that a lot of cell-based therapies, CAR-T and NK cell therapy, all has, has been extensively being used and translated to the clinic in Western countries and as well as China, maybe probably 10, almost down 10 years back, actually. And when you carefully look on, these were the technologies very well developed there and validated there and translated from the laboratory to the clinic very easily, actually, okay. Now, this technology is available now. In order to adapt this technology to the Indian context, it took a lot of time. Everybody knows that, actually. And the primary reason is that, it's very simple reason, is that the academics as well as industries are not in a position, they have not reached to a level of even a technology well perfected outside in terms of gene therapy or cell-based therapy, even to accept and translate in Indian conditions. And it took almost 10 years to start a clinical trial of CAR-T cell therapy in India. And then all we talk about that, whether this is that same technology is not the question of new technology development for the treatment, actually. What we giving more focus is that whether this is going to be economical or not, actually. Okay, now, and here, why it is not economical? We thought that our capabilities are not that level. We do not have an ecosystem to immediately translate such advanced treatment where a lot of engineering, biotechnology engineering, culture, cell culture in CGMP facilities, all they are not available. It is true that they are not available in sufficient numbers in many places, actually, and is restricted only in some pockets. But the economical side, when you look, actually, even something which has been translated in India, and are we comfortably placed in terms of facilitating an economical level of translation? No. The reason is that many of the peripheral reagents which is required for the cell expansion and activations and also validation all require specialty reagents, all still coming from abroad, actually. And as an institutions, as an academicians, all we are capable of doing and generating these cytokines in a scale at the laboratory level, actually. And why we failed? The primary reason is that we do not have an ecosystem to talk with a next level of translation of these small peripheral biological reagents which you can generate very well in high precision in laboratories. You have a startup. They are not capable of understanding. You have a big pharma. And we are not very keen to know the language of the pharma. We do not have actually an ecosystem in academic institutions to facilitate such translation. And I have seen something similar to that kind of an ecosystem in Sri Chitra. It's called Technology Facilitation Center, actually. They have something, it is not startup, in an academia supported ecosystem where a technology has to go to an industry. There is an intermediate level of a new ecosystem where the company who is going to receive comes and work in the ecosystem, not in the laboratory level. That kind of many models are to be generated if really a biotechnology product or precision medicine has to be translated in successfully to the bigger industries. That is very minimum in India. We need not one, the kind of population are kind of burdens which we have, especially in healthcare. You need large number of models. And obviously the DBT knows about this. That is probably the one thing, the bio-enabled hubs which is going to be established. And where it is to be established, that is a question. Whether it is going to be a centralized, an independent ecosystem away from the academic setting, or it is to be established in a near academic settings. That is more important. And that probably, everybody needs to talk about and discuss about that actually. And then only all these kind of bio-based products will become economical and also be acceptable to the community.
Thank you, sir. So, to Dr. Ambadi. So, one of the the policy proposed several strategies, and one of the major aspect of this policy is developing a large trained workforce in the country. That means because this is going to be a biomanufacturing revolution, and we need several trained people to achieve this dream over a period of time. And since you are heading a bio incubator facility, so what is how can you briefly tell us like how a ecosystem like a incubator facility can be a part of this biomanufacturing revolution, especially in promoting startups or encouraging people to become entrepreneurs?
As I initially said, one of the most fascinating aspects of this policy is the focus on promoting entrepreneurship, so that we can actually create commercially viable products and services that can be marketed and which can create revenue and boost our economy. So I think one of the important aspects of BioNest, which is actually a joint venture of Rajiv Gandhi Center for Biotechnology and Kerala Startup Mission, is that we have married a kind of a startup ecosystem with the biotechnology environment, and we have that kind of a centralized facility where biotechnology incubatees can come, incubate their ideas. We have just recently started an idea called pre-incubation. If you have an idea which is not mature enough to be an incubatee, then you can have a pre-incubation facility there where you can take the help of senior scientists from RGCB, the people who are there in BioNest, and develop that idea. And if it matures out and if it qualifies to be seen as a commercially viable idea which is worth incubating, then this pre-incubatee can become a proper incubatee. So another aspect today is the Executive Council meeting of BioNest that is happening in RGCB only after this meeting. So in that, one of the ideas we are discussing is a concept called product school, where actually even through biotechnology students who are studying in colleges, or even people who are interested in that, if they have an innovative idea to develop a product or something, and how BioNest can harness those ideas and help them in developing and marketing it. So that kind of a product school kind of thing, that where we are going into the colleges and giving them those ideas and helping them in coming out with some of their ideas, because they have ideas which has to be realized. So giving them expert technical advice, giving them facilities here, motivating them, maybe giving them some initial kind of resources to start that work. So that idea is also being discussed. So I think that we should be, as Dr. Santosh was telling initially, the policy is just a framework. From here we have to develop concepts and make into actionable points. So I think it will be a welcome step, and I'm looking forward to see good ideas and good entrepreneurs coming up from the sector of biotechnology.
Thank you, Dr. Ambadi. Now we are opening the forum for discussion. So now let me ask my colleagues and students at Akulam to raise the questions to any of our experts in the panel.
Hello. My question is to Professor Padmanabhan, sir. So when we talk about biomanufacturing, even now, 70% of the raw materials and reagents used in life science research and manufacturing are imported. So mainly due to the reliability and quality issues. So for example, FBS and media. So do we have a policy to manufacture this product with international quality? If so, what kind of globally accepted QC and certifications we can provide?
It's a very important question, because even you take your laboratory chemicals, other than a few, maybe sodium chloride or carbonate or few chemicals, most of the bio-based products are imported. For research, for example, Sigma is the Bible. So, when, because I have always discussed this with companies, they said, no sir, it's not economically viable in India to manufacture. But I somehow feel now climate has changed in India. We are ready to manufacture. India, as somebody said, we know in terms of statistics, 130 billion US dollars, etc. We are reaching there. Therefore, unless we make, the question is very relevant because many of these uh, components that are needed are not manufactured in India. That's, we import them. So, one of the opportunities, in my opinion, is for all these companies to make these products, components first of all, individual components and sell them. There are very few, I used to chair this BioE3, and few companies used to come in BioE3 and then say, we want to manufacture these products. It's not a ultimate product. These are all components necessary to make a product. Therefore, it's very important. First of all, we need to make these products in India. And digressing a little bit, I don't know how many startups are there in every institution, whether it's a CSR institution or DBT institution or universities. Because there is always this worry, you have to produce a PhD. And then they will say, no, this is not viable for a PhD project. Therefore, it's important to, to say that, all this manufacture of these products should also be eligible for a thesis. You can get a PhD out of making products or components of products. It doesn't have to be always some, so-called basic research. It can be, of course, basic research is needed for any application. But application-based products also are also important. So the climate has to change in India. I don't think we are still manufacturing a lot of things. We are importing a lot of things. This is the fact of the matter. Yeah, I'll stop here.
Thank you, sir. Any other question from?
My question is to Dr. K. M. Bedi, sir. Sir, you described some impressive figures about the economy, but and if we go back in 2014, where the government of India started the manufacturing in India program. So, but the policy initially got a lot of hype and promised a lot, but the current and the real scenario is that one of the principal component of policy was that it will provide 100 million jobs. But the fact is that the policy, currently we are short of jobs, and which are around 9 million as promised. And also you talked about the economic rally and other things we have currently. But the thing is that our GDP is declining by 4%, and our debt is increasing by 90%. So keeping this all in view, how the BioE3 policies will handle these situations, and what are the intentions of this policy that should be taken to avoid these pitfalls?
So that is a very relevant question because whenever we are coming out with something, a new policy or something, so there will be always, we'll be talking about fancy figures, we'll be talking about very high aspirations. And when it is getting translated to reality, as the questioner was asking, there will be, the realization of that potential would be less. But I would always like to see the glass as half full rather than half empty. So I feel that actually, just before this discussion, we were having a chat with Dr. Santosh. So he was also telling that probably this policy could have been inspired from a recent policy that has been adopted by the US government. So I think that here we will have a first mover advantage. And if all of institutes like us, can take the lead in utilizing this opportunity to open up the available resources. Because what happens is that most often we will see it as an outsider and say that they have not done it. But what I feel is that people who are all working here in Rajiv Gandhi Center for Biotechnology, in all other DBT institute or institutes of science and technology, we should take that onus of utilizing a policy, because the government can only come out with a policy guideline, they can give us funds, but it is for us to actually really work on that, use that opportunity and take it to the next level. We cannot expect the government or any policy making body to do it for ourselves. As we say, only 10 can take a host to water, but 10,000 can't make it drink. So I think that we have to drink the water ourselves. We have to utilize this opportunity and this beautiful policy that has been formulated. Of course, we may have previous experiences of not realizing such goals. I think that we should also take the responsibility partially for that. We cannot actually shift the responsibility and utilize that opportunity and the available policy alternatives, make best use of it and find some results for it. One example which I can tell is that actually when this policy is being discussed itself, the call for the biofoundry is open. And I think that Rajiv Gandhi Center for Biotechnology under the leadership of Dr. Santosh has already applied for a biofoundry, and that used to be, if I am not mistaken, in the animal model kind of thing and in public-private partnership. So I think that we should take lead role in that. And with my experience in government, what I found is that if you have to do something, if you can do something, there is an opportunity, definitely there is a space for doing. There is nobody prevents you. But the problem is that even if you don't do, there is nothing will happen to you. So most of the people will take the second route of taking that lackadaisical attitude of not doing. So I think that it is an opportunity for all of us. We should take that opportunity and do whatever we can and make best use of this policy and make this policy work. Thank you.
So we can have one more question from Akulam campus after that, because we are almost reaching to our time limit. So now it's open to people in the auditorium. So please.
Am I audible? Yeah.
Yeah.
So the question is for anyone. It's a general question. Till last year, August, when we had a meeting on the biomanufacture, the smart protein, so the FSSAI has were yet to come up with the rules and regulations for the clearance of the food if it is being produced. So is that yet ready, or we are still, it's still on the working level? So that is first question. And the second question is, few of us are really trying to get it into the smart protein thing, but how is the government or the policy making body are arranging for the acceptance of those products to the mass? Whatever I have understanding, I don't think the people of this country are really ready to accept that smart proteins, what we are planning to do. But so what the government or the higher authorities are planning to change that idea for the acceptance to the mass?
Yeah, regarding FSSAI, still its smart protein is not cleared, but the easy way to get the clearance, there are ways to get a clearance. So I can tell you, if you are saying you just claim only the major ingredients which is commonly used by us at this time. If you say most of the time the documents which they submit, which is not, we are not interested on talking about a process in the license body. The license giving body actually looks for only ingredients. You focus on ingredients, don't say smart protein or any of this, just say it's a high protein food. Then you will get a license faster, because those rules are already framed and kept. For the policy, for the administrator to clear, that is easy. But if you say smart protein, for the body to understand that protein, it will take quite a lot of time. Okay, that is one of the suggestions I can tell you. But still the policy is not ready on smart protein. Even only now that policy is coming out for even microbial oils, because even that policy is not there and we are forcing. And that is one of the difficulties which we have on this. But when it comes to consumer acceptability,
Yeah.
it is not that you and me can debate on this. The only way to go is just go hit the market and really see it. Number one. Number two, because smart protein, none of our population is to pay 1 paisa extra than what you are asking for. In fact, the smart protein which you are making, it should be cheaper than the conventionally available protein. Then yes, you will hit the market very effective. This is my personal experience. Because people talk about they want quality and quality, they want the highest quality with the minimum price. This is our attitude. Our population attitude is this. Okay. A typical example is they will spend all the money and write it to a doctor or a hospital on name of some disease the doctor said. They never spend 1 rupee extra for looking after their own good food and their health. This is our attitude. This is difficult to change the mass. And you need to cater your smart protein to the people who take the mass. People understand smart protein, not going to public funds. That was my suggestion.
Yeah, basically, smart proteins still being an academic interest because even whole country is looking for more innovation on how you will, if you conceive a product which can be generated in the laboratory using biotechnology environment, what more important is that when you translate this initial product into the market ready conditions, how much innovation you will do to make it more economically viable one actually. That is where actually I feel that rather in addition to conceiving a product from the lab, a lot of innovations needs to be done in that aspect to make it actually affordable in addition to the smartness actually, then only it will be going to be that. Actually speaking, a lot of research has to be done in that domain actually, when you go from the lab scale to the industry scale. And it is possible as well.
Research is, yeah, of course it will be there, but research will also develop, but if the acceptance won't be there, there won't be any point of developing those products, right? So that should also, I think, start parallelly to make people understand the importance or
Okay.
like that. That's what I was thinking.
Yeah, that is true actually. No, it
I have a
doesn't.
small suggestion. Young people like so what are called as junk foods. Whether smart proteins can become part of junk food. It
Yes, it can be marketed like that.
comes up with something very attractive, and I'm sure it will take off. But government cannot do it by policy. Government can only help, but its industry, I think, can attract. If junk foods are so popular, I don't know why smart proteins cannot be. It should become part of it. Make something which is very attractive.
Thank you, all panelists. So, any other, yeah.
Yeah, I have a question to Professor Ram. So I asked this question on Teachers' Day because the question is actually a follow-up of what my colleague has just asked. Because it's an excellent policy, but one point I find lacking in the policy is the fact that there is no path of educating the people about this change of materials that's going to come in the next 20 years. Because if you're going to create something, for example, when I was in my master's, we had BT cotton and BT brinjal, which is still in the incubator, which has not yet been released into the market. I mean, field trials are done, closed trials are done, but people are still not reluctant to accept it unless there is a path of addition of educating the people that this is okay, this is safe. There won't be a viable or economically viable path for these kind of materials. Similar is the point that Dr. Santosh has actually put up. When we had COVID, we had materials and reagents which were equally good that was can be used for detection of COVID, but none of the agencies or these testing agencies were clearing it out as a standard. We were still dependent on foreign material because so one thing, the policy that I feel that is lacking is, it's an excellent policy, but educating both the people and also these agencies who are actually going to accredit them, these kind of changes need also to be educated that there is a change. These are the changes that. So, what is your view on this? How can we overcome? Because end of the day, these things have to come out. There should be a market to be sold.
The question is very pertinent at this time, but very interesting thing about a market which you should understand. The consumer has the choice of rejecting you anytime. By educating them, the amount of time required to educate, it is too expensive even running an operation of any of these, because that is the very important. For example, even biotechnology was instituted as a separate department for a long time ago. Even till today, the public has not accepted the pitti brinjal. At least cotton they can try work it out, but pitti brinjal is not into any of those kitchens. But what can government can do? But government thinks they cannot do. No, they can do very well. What they can do? Most of the procurement, which is for the public consumptions, like schools and most of these government operations, which includes military and all these places, they can buy the products of this kind and then introduce them and use this, start using, that way the industry can start growing. Because you are asking an industry to go and educate a consumer, that is not possible. It's very easy to say. But the consumer always thinks, what I want, I will get. Why should I learn this to really buy your product? This is the attitude which comes in. But still the policy can be developed, a material which is new and it has a problem, but it has a potential. But still, all these material can be used as a part of the government programs, and that is the best way to go. That policy change and a political change has to come. If it is not coming, and then whatever the smart thing which you are developing, as long as your product is cheaper than the existing, no consumer going to pick it up. That is the main crux of the whole part. Now, for biomanufacturing, if you are concerned, now we have not educated the educated people. Like we don't have a skilled manpower at this time. It is the time biotechnology has to say they have some program called, earlier they had bioinformatics under biotechnology. They should have biotechnology under this biomanufacturing as a part. That is the initial part of bringing students, and then slowly they will educate the population. And that is the long process to happen. If the product is cheaper, and then the learning process is not possible. You will just incorporate and done with it. Like our Professor GP said, okay, whatever you have put on a junk protein, junk food, you put a good ones, you will keep moving your market, and the industry will survive. And that is the important part. Educating consumer, no company can take up as a process, only the government can take up the process. If a good biomanufacturing comes, most of the product, government can start using those products for their own programs. That's the best way to really encourage all the industry to really produce this. Otherwise, no industry, they will produce something, okay, it is not going to market, they shut down, move on to something else. This is what happens as an industry.
Thank you. So, due to lack of time, if you have any other questions, you can send to me. I will circulate among the panelists. Before I conclude, let me invite the director, Professor Chandrabas Narayana, to say a few words, and after that we will end the program.
Good morning, everyone. Professor G. Padmanabhan, my teacher. Happy Teachers' Day, sir.
Thank you.
And Professor Ram Rajshekaran, Ambadi, and my colleague Santosh and Hari, my colleagues in RGCB, both campuses, as well as students and ladies and gentlemen. The whole idea behind this exercise of having a panel discussion on this policy, which has been brought out by the Government of India, was to get the views of eminent people as well as commoners to understand what they realize about this policy. And this was actually an initiative done by the Department of Biotechnology, and we happened to be part of it. So I didn't want to be in the forefront to discuss and popularize. I wanted to hear from most of the people around, and we want to actually get to understand what do you think about a policy. Many of you have discussed about this, and I just wanted to mention policy is in a paper. Policy doesn't get anywhere if it is not implemented. So this is where the stakeholders are there. This is where the thinking has started. You have started asking questions. You have started, how is it going to go forward? This is what we wanted. We want people to realize that every one of us is actually involved in it. If you are looking at economy, and some of you mentioned about the GDP and other aspects of it, economy we have actually been not contributing before probably about 50 years after independence. We have not been contributing anything from the biotechnology. In the past 15, 20 years, we have started actually making a big leap in production of biotechnological products. But there was no policy existing in the country. There was no clear-cut ideas about how to do it. Biotechnology was part of all the other kind of industries which we existed, and hence there was no facilitation. And many of you have actually pointed out there is no ecosystem. This policy actually gives you that ecosystem possibilities. We need to work with the politicians, with the government, with the bureaucracy, with the academia and all of those things, and try to empower ourselves to be able to manufacture things in India. And many of you have pointed out rightly, and many discussions happened because of that, is that we do not actually produce many of the things. And COVID was the reason when we started realizing that there is a need that we need to be independent of the developed world, which actually makes everything for everybody else. India is actually in a position today to actually be a leader in biomanufacturing. There are two reasons I say this. I am a proud Indian, I always say this, because we have a human touch to it. We are not only interested in making money. We are also interested in helping people. And that is the only country which has that kind of an ethos, and that is what all of you are, and that is why India should be a leader in manufacturing. And I think that is what many of the developing countries would be looking forward to from India. So this is the right time. So all the other aspects which you have been discussing of how the human manpower will come, all that are ingrained in the whole policy itself. If you actually read through the fine prints, you will realize that you have brought together, this is not biotechnology, is not no longer a ministry. It is actually bringing together space, it is bringing together DAE, it is bringing together institutions which are actually earlier working independent of each other. And they have all been brought together under one umbrella, and this policy is actually helping in bringing a synergy between all of these things. And that's the beauty of this particular policy. If you have actually gone through the policy, you will realize there are many futuristic things which are actually possible in this policy. Limitation is us. So as an academia, I'm telling about RGCB kind of institutions, what we need to actually look at is how do we actually educate around us about this policy and get people to work with us and do it. It cannot happen if you expect government to do everything. It has to be us. We need to actually take this policy forward. We need to work and bring about a change in the ecosystem. Actually, Ambadi mentioned that. Many a times, we are expecting things to happen for you. It should not. We need to actually now go beyond that and try to make sure that this happens. And that's basically what, as academicians, we have to do. We have not been making our manpowers, and I have been always one of the proponent of saying that we produce way too many PhDs. I'm sorry to say that, but we are producing way too many PhDs, because today I was actually looking at the job market. Many of the biotechnology industries do not want a PhD. seriously I'm saying, then what are we producing PhDs for? Then they should be the ones who are going to give employment. If those PhDs which you are producing should be giving employments, because that is what your research has to do. Your research has to do that these PhDs should produce jobs for others, because they are not going to get a job in an industry. Seriously, I am telling this, and this policy is meant for that. And I hope all of you understand that, and I hope this is passionately talked about. We change our kind of research. We try to make our students actually employers. And that's what is this policy about. And I hope we work towards that as institutions. And I hope if we do that, there will be a changed environment around us. Thank you. And I would like to thank all the members who have participated in the panel, especially to Professor G. Padmanabhan. I revere him so much, as well as Professor Ram Rajshekharan, my colleague Ambadi and Santosh, and all of you for coming. And I'm hoping that this is the beginning. It is not the end of it. Thank you.
Thank you. We are adjourning the program. Thanks again for joining us today.